Hey, ladies and gentlemen, this is Miss Humbert here, and today we're going to be doing Unit 7, Notes 7. So, today we're going to be talking about tangent lines. Now, this is different than when we talked about tangent, the cosine function. So, we're talking about actual tangent lines. So, let's go ahead and take a look at what tangent lines are. So, taking a look at tangent lines. So, what is a tangent? A tangent is a line that intersects a circle at exactly one point. So, oops, I got to get my pen going. Come on. A line that intersects a circle at exactly one point. Okay, so it has to be at exactly one point. It can't be at two, then it's not a tangent. Okay, so then what is the point of tangency? Well, that should kind of make sense to you. The point of tangency is the point of intersection. Okay, so that's the point of intersection. So let's go ahead and let's take a look a little bit about what that looks like. So right here, A is the point of tangency. If you see that this line only hits the circle once, okay, so then its tangent, the point of tangency is A. So sometimes circles have two common tangents. So for example, line L is tangent to both circle F and circle G. You could also draw another line of tangency here that would be tangent to both. That could be, say, M. Same thing with L in the second one. L is tangent to both circle F and circle G. So sometimes lines can be tangent to two different circles. So let's take a look at possible tangency. So we're using a straight edge. So maybe pull out a piece of paper, something that you can use to draw straight. So we're trying to find and draw common tangents. Well, I notice that I can draw a tangent going down this way, and that tangent is going to touch each circle once. Likewise, I can draw another tangent going across this way, and that's going to cross each circle exactly once. Okay, so then for this one, it's hard to find a tangent point. Like you could go like this, and it's tangent to both, and like that. Then for the next one, it's kind of confusing for this one, but they both cross at this point right here. So what I can do is I can draw a line that's tangent to that point right there. Now hopefully you used a straight edge, so your tangents are a lot prettier than mine are. Let's go ahead and let's take a look at theorem 10.10. In a plane, a line is tangent to a circle if and only if it is perpendicular to the radius drawn to the point of tangency. So what does that mean? That means we have this radius ST for circle S. In order for line L to be tangent to it, that has to form a right line or a right angle. So where the radius and the point of tangency are needs to be a right angle. So let's go ahead and let's take a look at number 2. Is KL tangent to circle J? Well, here's my radius on circle J is JL. Then I have this point of tangency, which is 15. Okay, so I want to figure out if it's a point of tangency. And to do that, I need to see, is that a right angle? Well, I notice I have a triangle here, so I might want to use the Pythagorean theorem. Well, this length right here is 9. Then J to this point is a radius, so that point is 8. So let me go out and draw my new triangle now. So I have 15, I have 8, and now my hypotenuse is 17. So what I need to do is I need to use the Pythagorean theorem and see if it's true. So I'm going to, this should be 15, not 18. I'm going to square my two smaller sides, or my legs, and set it equal to my hypotenuse. And if it's a right angle, the two of those should be equal. So then I end up getting 225 plus 64. Is that going to be equal to 289? So then 225 plus 64, you get 289, which is equal to 289. So the Pythagorean theorem holds true. So yes, they are tangent. Okay, let's take a look at number 3. Is GH tangent to circle F? So to see if that's true, we need to see if that guy right there is a right angle. So I notice that we have a supposed right triangle. So we take our legs and we square them, and we set it equal to the hypotenuse squared. That already gives us the hypotenuse. So 8 squared plus 6 squared, so then you get 64 plus 36 is equal to 144. Then I end up getting 100 is equal to 144. Well, is that true? No, that's not true. Okay, so no, it's not a point of tangency because that doesn't form a right angle, so GH cannot be tangent to that circle. Let's take a look at these next one. Find the value of x. Assume that the segments appear tangent are tangent. So we're going to assume that that guy right there is a right angle. We're just going to assume that because it looks tangent, and that's what the directions tell us to do. So we need to use the Pythagorean theorem to figure out what x is equal to. So I have x squared plus 12 squared is equal to x plus 8 squared. Okay, so that looks a little confusing, but we can handle it. So I have x squared plus 144 is equal to, now when you have x plus 8 squared, that's where you have to use that box method where you have x and 8. We're basically taking x plus 8 and multiplying it by itself twice. So then I'm going to multiply into the box. So I have x squared plus 8x plus 8x plus 16. So then this is x squared. Then I can actually add 8x plus 8x to get 16x. Plus 16. Or I'm sorry, 64. Goodness gracious, I can multiply. So this should be 64 right here. Okay. Now we're back on track. So first of all, I notice that there's squares on both sides. So those squares are going to actually cancel out for us. So then I end up getting 144 is equal to 16x plus 64. So now I'm just solving an equation for x. So I'm going to go ahead and subtract 64 from both sides. And I get that 80 is equal to 16x when I subtract those. So now to get my 16, or my x by itself, I need to divide both sides by 16. And I get that x is equal to 5. Okay, so that's what the problem wanted. It wanted us to solve for x. Now, letter B is a lot more simple, okay, because we know that this right here is a right angle. So again, we're just going to use the Pythagorean theorem to solve for x. So x squared and x and 14 are our legs. So we have x squared plus 14 squared, and we want that to be equal to 17 squared. So let's do some math. So we have x squared, 14 squared is 196. 17 squared is 289. So now I want to get that 196 over to the other side. So I'm going to subtract 196 from both sides. Then I get that x squared is equal to 93. So how do I solve for x? Well, I have to get rid of that x squared. So I'm going to take the square root of both sides. The square root of 93 gives me 9.64. Remember that you need to watch your rounding. So type it in your calculator. Make sure you understand how to round it correctly. So that's your final answer for letter B. Let's take a look at another theorem here. If two segments from the same exterior point are tangent to a circle, then they are congruent. Okay, so if they're tangent to the same circle and the same exterior point, so if AB is tangent, so if these two lines are both tangent, so let's write that. If the line segment AB and the line segment CB are both tangent, to circle D, and they connect to B, then we can say that AB, that line segment, is congruent to CB. Okay, so I'll give that a second to cross. So they have to be tangent to the same circle, and they have to reach out to the same point, which in this case is B. So let's go ahead and let's take a look at this example. So find the value of x. So I notice that they're both tangent to the circle D, and they're reaching out to point B. So that means that these two lengths are congruent. So that means that x plus 15 is equal to 2x minus 5. So now I need to solve this for x. So I see the smaller amount of x's here. So I'm going to go ahead and subtract x from both sides. Then I get 15 is equal to x minus 5. So last but not least, to solve for x, I need to add 5 to both sides. And then I end up getting that x is equal to 20. X is equal to 20 for that one. Next, let's take a look at number 6. So for number 6, I noticed that QR and SR are tangent to circle T. They also meet at point R. So then again, 3x plus 8 has to be equal to 26 because those two line segments are congruent. So I'm going to go ahead and subtract 8 from both sides, and I get 3x is equal to 18. Divide both sides by 3, and I get that x is equal to 6. So that's my final answer for number 6, is that x is equal to 6. Now let's take a look at polygons. So a circumscribed polygon is a polygon that is entirely in a circle or surrounding a circle. So you notice that the entirety of this polygon is around the circle. Same here and same here. Where if you look at these, the circle doesn't fill it or the circle sticks out. It kind of almost has to perfectly fit in order for us to say that it's perfectly circumscribed into the polygon. So let's just take a look at an example of that. So for this one, number 7, it asks us about circle J, and its perimeter is 18 units, so we need to find x. Okay, well here I have a line of tangency, AS and DS. So I notice that AS and DS meet at point S and they're tangent to the circle. So that means that this guy here also has to be 3. Same thing here, DR and CR are tangent to the circle. They meet at the same exterior point, so this has to be 3. Then I have this CU and BU are tangent to the circle and they're both reaching at point U, so that needs to be X. BT and AT are both meeting at point T, they're tangent to the circle, so this has to be X. So I have 1, 2, 3, 4X, so 4X plus 3, 6, 9, 12, and that has to be equal to the perimeter, which is 18 units. So now we're just going to solve this for x. So I'm going to take 18 and I'm going to subtract 12 from both sides. So then I get that 4x is equal to 6. Then to solve for x, I'm going to divide both sides by 4. And then I end up getting that x is equal to 1.5. And I'm going to label that units because that's the label that they originally gave us. So that concludes your note video for today. Go ahead and show me your completed note sheet once you're done. Thanks for listening.